Whoa.
Alright, today, as I mentioned, we're just going to look at equations of parallel and perpendicular lines. So, some of this note sheet looks just like what so we're not going to do this whole note sheet. We're just going to do a few specific examples. Okay, I want to start down here in the exercises. Okay, where it says determine whether these two lines are parallel, perpendicular, or neither. So yesterday we did problems like 3 and 4, right, where we had to find the slope between points and determine whether the slopes were the same. But we didn't really look at ones where we were just given equations. So if I look at number 1, okay, I want to determine whether these two lines are parallel, perpendicular, or neither. So first we want to figure out what the slopes are. What's the slope of this first line?
3x.
So 3. Right, we would just say the slope is.
Would it be 3 over 1?
So yeah, technically we could write it as 3 over 1. Okay, so I can say this first one is 3 over 1. What's the slope of my second line? Same thing, right? It's also 3 or 3 over 1. So the slopes of these two lines are exactly the same. Are these lines parallel, perpendicular, or neither? Parallel, right? If we get the exact same slope, the lines are parallel. Okay, remember, parallel is same slope. Perpendicular is opposite reciprocal. So now, if we look at number 2, okay, again, I've got 2 equations of lines, but these look a little bit different. I cannot just look at these equations and see the slope. We have to solve it for y. We have to get y by itself. We have to make these look like this. So, we want to move the x. No, because it was already solved for y. It was already in the form of y equals mx plus b. So I can just look at it and see my m. So that's what we want to do here. We want to put these in this form so that I can just look at the equation and see my slope. So the first step will be to add 2x over. Yep. So we'll have 3y equals 2x plus 4. Then what would I need to do? Divide it all by 3. Exactly. So I'm dividing everything by 3. Right? So we'll end up with y equals 2/3 x plus 4/3. So what is the slope of this line? 2/3. Right? The slope is 2/3. So now we want to do the same thing for 4x plus 6y equals 13. Okay, so go ahead and do that real quick. Solve that for y. Figure out the slope. Do the same process for the second equation. Solve this one for y. And remember to reduce any fractions.
Negative 4 over 6.
What do you mean an equation? Yeah, so we would divide everything by 6 here. Yeah. Also, I mean, the 6's cancel out over here. Can I reduce negative 4 over 6? No. Oh, okay. It'll be negative 2/3. I can divide each of those by 2. So I can make this negative 2/3 x plus 13/6. So what is the slope of my second equation? Negative 2/3. Can it? How? Yeah. We got positive 2/3 here and a negative 2/3 here. So that's going to be neither. Okay? So if we think about what those slopes would look like, right? If we graph those lines, a slope of 2/3 would mean, I go up 2, right 3, up 2, right 3. So this would be like a slope of positive 2/3. Well, a slope of negative 2/3 would mean I'm going down 2 over 3, down 2 over 3. Right? So we would end up with something like that. So those lines aren't parallel. And they would in fact be neither parallel nor perpendicular because they're not the same and they're not reciprocals of each other. So this example would be neither. Okay? So the idea here is if we have equations, if they're in slope intercepts, we want to just be able to look and see the slopes and then compare them. Sometimes they're not in slope intercept form. Sometimes we have to put them in slope intercept form. Okay? But then we still just want to look at the slope and compare. We okay with something like that?
Yeah. We were 3 or 4 times.
We actually did these exact problems yesterday. So
We did -7 minus parentheses.
right.
Minus 0.
Right.
I just want to go over this one shot.
The negatives and positive. So,
Right. Yep.
you go on the back.
Yep. We're gonna go to the back. Okay, so since we already did 3 and 4 yesterday, we're gonna go ahead and flip over to the back. Now, we actually did 5, 6, and 7 here yesterday as well, but we did them graphically. Today, we're going to do them as an equation. So, if I look at what I'm given in number 5, okay, I'm given a slope and a point. If we remember, the two different forms of a line that we've talked about are y equals mx plus b, which is slope intercept form. And then the other form that we've talked about was y minus y1 equals m times x minus x1. And we called that point slope form. So if I look at the information that I'm given here in number 5, I'm given a point and I'm given the slope. So which form of the line should I use? Point slope. Right? If we're given a point and the slope, we use point slope. So that's y minus y1 equals m times x minus x1. So that's we've been working with that equation for a few days. Yeah, so this slope is m, right? And then my point is x1, y1. So I'm just going to plug those 3 pieces of information in. So I'm going to have y minus 2
Equals 4 parentheses times x minus 6.
Yep. So now, the directions say write your final answer in slope intercept. So what that means is I just want to take this and solve it for y now. So I'm going to distribute this 4 through. So y minus 2 equals 4x minus 24. Then add the 2 over. And we end up with y equals 4x minus 22. So given a slope and a point, we use the point slope form. That's what we're going to be doing for a lot of these here. For the next couple, though, we have one step we need to do before we can do something like this. So if I look at number 6, it says we want to write the equation of a line that goes this point. So we're given a point, just like we were in number 5. But then we're not given a slope. We have to determine the slope out of this second piece of information. It says we want a line perpendicular to 2x plus 3y equals 12. Perpendicular automatically tells me opposite reciprocal slope, right? Opposite reciprocal slope. What is the slope of this line? We don't know yet. Y is not by itself. We have to solve this for y. Just like we did on the front. So subtract 2x over. 3y equals negative 2x. Oops, not negative 2 over x. Negative 2x plus 12. Then divide everything by 3. We'll get y equals negative 2/3 x. 12 divided by 3 is just 4. Okay, so this is the equivalent form of this line. So what is the slope of this line? Negative 2/3. But I want my new line to be perpendicular. So what should my new slope be? Positive 3 over 2. So I want to go through this point, 8, 5. So what we've done now is created a problem just like number 5. We have a slope, we have a point, we want to write the equation. So I'm going to take this information and plug it into y minus y1 equals m times x minus x1. So this is my m, my x1, and my y1. So if I plug this in, we get y minus 5 equals 3 halves times x minus 8. And again, we want to solve this for y now. So I will distribute this 3 halves through the parentheses. So y minus 5 equals 3 halves x. What's 3 halves times negative 8? Negative 12. Okay, we can just do that in the calculator. Then the final step would be to add 5 over. We get y equals 3 halves x minus 7. We okay with something like that? Now, the next one, again, they negative 2, 5. But now they say we want our new line to be parallel to LB, and they just give us the points, the coordinate points. So if they just give me the coordinate points, how am I going to find the slope of line LB? Four minus 1 over 7 minus 2. Yeah, we're going to use our slope formula. Okay? Y2 minus y1 over x2 minus x1. So if I label my points, x1, y1, x2, y2, plug them in. We'll have 4 minus 1 over 7 minus 2. So that just gets me 3 over 5. So the slope of line LB is 3 over 5. I want my new line to be parallel to that. So what's my new slope going to be? 3 over 5, right? Same slope. So we're going to take that slope, 3 over 5, and the point, negative 2, 5. And do the same thing that we were just doing, times x minus x1. So negative 2 is my x1, 5 is my y1. So we'll have this 5 equals 3/5 times x minus negative 2. So that would be the same as x plus 2. We just want to do the same thing. Distribute this 3/5 through the parentheses. So we'll have y minus 5 equals 3/5 x. That's 3/5 times 2. 6 over 5, right? And then the last step would be to add 5 over. So we'll get y equals 3/5 x. 6/5 plus 5. It's going to be 31 over 5. Okay? You can use a calculator to do that. And you don't have to try to do that by hand. Alright, so that one we got an ugly number at the end. But again, just use your calculator. You okay with this process? Alright, let's take a minute or two and see if you guys can do the last one here. Okay? So we're given our points, but I want my new line to be perpendicular to this line right here. Okay, so let's take a minute or two and see if you guys can get this one.
Whoa. Sorry for the song.
Slope. So what's your slope of that? Yeah, so your slope of this line is 3. So now I want my new line to be perpendicular to that. So what's my new slope going to be?
The same slope.
Negative 1.
This is 3 and 1.
Right.
Is it going to be M? You got this. What do you mean? You got the same slope? So if you want the slope of this line is 3, that needs to be perpendicular. So if you do 1.5, I already beat you. You can't say you beat me.
Yeah. So for this one, right? For this one, you could have solved this out and put it in slope-intercept form, okay? Or we could have just said, well, my point-slope form shows me the m as well, okay? So my m, my slope of this line, is right here. It's just 3. But I want my new line to old slope was 3. Well, remember, this would be the same as 3 over 1, right? So if I want the opposite reciprocal of 3 over 1, that's going to be negative 1 over 3. And then I wanted to go through the point 4, negative 3. So I'm going to take these 3 pieces of information. My new slope is negative 1 over 3. And my point is 4, negative 3. So if I plug those 3 pieces of information into point slope, I'll have y plus 3. That's y minus negative 3 equals negative 1/3 times x minus 4. When I distribute the negative 1/3 through, subtract 3 over, we end up with y equals negative 1/3 x minus 5/3. So the key for these is parallel means same slope, perpendicular, opposite reciprocal slope. Okay? Questions?